Video on the series on differentiation, and in this video we will cover implicit differentiation. Up until now, we have been dealing with functions explicitly in terms of x, whether it be y equals x squared or y equals sine x. All of these functions were in terms of x. But there could be more complicated functions that we can't solve for y in terms of x. Consider the function y to the fourth plus xy squared plus x cubed equals 0. Now, unlike these two simple functions, we can't solve for y in terms of x. So we have to find a new way to find the derivative of the function, to find dy dx. Another notation for the derivative of a function y of x. The way we do this is by taking the derivative of each term, but doing something special when we take the derivative of a term involving y. So using the power rule, we can surmise that the derivative of y to the fourth is 4y cubed. But since this is y, and y is actually a function of x, we can consider this to be the inside function if you recall the chain rule. And therefore, we must also write the derivative of the inside function, dy dx. So essentially, every time we take the derivative of y, we accompany it with the term dy dx. So similarly, when we take the derivative of xy squared using the product rule, first we take the derivative of x times y squared, which is simply 1 times y squared. Then we take the derivative of y squared, 2y times dy dx times x plus 3x squared using the power rule equals 0. The next step is to isolate dy dx. And the way we do this is by bringing the terms without dy dx to the other side and then factoring it out. So we have 4y cubed times dy dx plus 2xy dy dx equals negative 3x squared minus y squared. And now, factoring out dy dx, we have dy dx times the quantity 4y cubed plus 2xy equals negative 3x squared minus y squared. And finally, dividing by this term in parentheses, we have dy dx equals negative 3x squared minus y squared over 4y cubed plus 2xy. And that is our final answer. So recapping, the way we take the derivative of a function where we can explicitly solve for y, we take the derivative of each term, and for every time we take the derivative of y, we write dy dx. The product rule still applies, the chain rule still applies, and all the other differentiation rules still apply. So if we had a function sine of xy, this would actually be quite complicated. Suppose sine xy equals 0. So first we would have to take the derivative of the inside function using the product rule, which would be 1 times y plus x times dy dx, since the derivative of y using the power rule is simply 1, and this whole quantity times cosine of xy equals 0. Then we can cancel the cosine term, and we'll find that dy dx times x equals negative y, and simply dy dx equals negative y over x. So once we do take the derivative term by term, we isolate the terms with dy dx, factor dy dx out, and then divide by the term in parentheses. In the next couple videos, we will do more examples involving the rules of differentiation covered in these 8 videos.